So this lesson is about plotting line graphs. Miss Alanot is joining me and may pipe in every once in a while.
Hello.
And so what we're going to do, first of all, I'm going to mention this is covered in your textbook, Science Perspectives 9, page 623 to 633. So we're going to go through some of these things together, and then we're going to leave some of it for you to finish off yourself. To begin, why are graphs important? In our opinion, graphs are important for two reasons. They summarize data as a mathematical diagram, and really what this allows us to do is it allows us to see trends in data more easily than, say, in a table of values or even in an equation. Okay, and what's really useful about this is that then unmeasured data points, things that we don't measure but that we want to be able to predict, we can see right there, and we call this interpolation. Okay, so we're going to go through the steps that are required to plot a line graph. Some of these you may remember from grade 8 and even grade 7 math and science. If you've had grade 9 math, you will definitely remember some of these rules. And we're going to go through what they are. So the first thing is to use a pencil and a ruler, because we use a pencil so that we can correct mistakes. We use a ruler because this is much more accurate. Okay, fair enough, that's pretty simple. The second thing that we want to be able to do is label our axes, always. And we need to include not only the quantity that we're measuring, but also the unit that we're using. Okay, so here's a very simple way to go over what goes where, and this is something that you're just going to have to memorize if you don't already know it, is that the quantity that is mentioned first in the title is always plotted on the vertical axis, and then of course the quantity that's mentioned second would be plotted on the horizontal axis. So here's an example. Plot a graph of speed versus time for the motion of a motorcycle. And what we would say then is that speed would be plotted on the vertical axis because it is physically mentioned first in the title. Now, some of my students say they still have a difficult time between getting vertical right and horizontal right. So there's a little diagram over here. Remember that the sun sets on the horizon. And the horizon is called the horizon because it is horizontal. Okay, so if you ever want to think about horizontal versus vertical, just think the horizon. That's the back and forth, but it's the kind of the direction where we would see the sun set. Okay, the vertical then is the up and down direction. So this is just kind of a nice little way to help you remember what's horizontal and what's vertical.
Very nice.
All right, so that's number 2. Number 3, we're just going to mention now, but then we're going to go into it in a little bit more detail in a little while, and that's calculating an appropriate scale. Okay, so a scale is how big do we make each square? And that can be very challenging. This is challenging for grade 11s and grade 12s. They always produce graphs that have terrible scales, but if you can remember the steps that we're going to show you, you will never struggle with this. It's really straightforward. So the number, basically number every square, every other square on each axis, and we're gonna take a look at how we do this in a minute. So let's just keep this in the back of our mind. We're going to come back to it. After you plot your data points, we're going to draw the smoothest possible line or a curve for these points. Okay, this is called the line of best fit, or the best fit line. Okay, if all the points do not fit exactly on the line, what do? We have equal numbers of points above and below. Okay, so this is one of those things that you will really help yourself if you have a clear ruler. So if you happen to have a ruler, or you use one that's in the classroom that's clear and you can see through, this sometimes can be very helpful. Last step is to write a descriptive title at the top of the graph, and you of course would want to remember that whatever you've graphed on the vertical axis would come first in the title. And so the effects, these are examples. The effect of beaker volume on the burning time of a candle is more descriptive than burning time versus beaker volume, right? So we would want to make sure that we have a descriptive title that uses the correct form. So having said that, what we're going to do is that we're going to come back to determining the axis scale. Okay, so really you can memorize what we have in these boxes, but there's a little bit, this is a little bit repetitive, and what you'll find is that if you do this enough times, you won't have to memorize anything, you'll just understand how to do it. So this is what we're going to do. How do you figure out how big to make the boxes? This is what we do. The value for each square is going to be the largest value that we have to plot on that axis divided by the number of squares that we have available. Okay? And so how many do we have available? In general, if you're using standard graph paper, you're going to have about 30 squares on the vertical axis and about 25 squares on the horizontal axis. This is in general how many we're going to have, especially if you leave room to label your axes. Okay? Then, and this is really the key, and this is what a lot of us have difficulty with, to make the data easy to plot, the value for each square is rounded up to a multiple of 1, 2, or 5. Okay, so let's practice that using a couple of examples here, and then we can fill in the rest of this chart. So let's say we get a calculated scale value of 0.162, and we want to round this to either a 1, a 2, or a 5. We would round this to 0.2. We can't round it to 0.1 because that wouldn't be rounding up. Rounding this value to 0.5 is too high. So we would round this to 0.2. 78.3. Yes, if we were rounding it to the nearest 10, we would round it to 80. But 80 is not a 1, 2, or 5 value, so we would round this to 100. 33.7, we would round that to 50, right? Because we're not going to round it to 100. We're not going to round down to 20. So that the most appropriate thing would be to round it to 50. So what I want you to do on the video now is to check these things off your list. So press pause on the video, and I want you to do these examples for yourself, and then come back, press play, and then check and make sure that you've got the right answer. So press pause now, you go and do this, and then we'll come back. All right, so if you've tried these on your own, 3.66, we're going to round to 5.00. Of course, we're not going to round to 2, we're not going to round to 1, so this would be rounded to 10, or sorry, to 5. 0.84, we're going to round to 1. 14.7, yes, it's tempting to say you're going to round it to 15, but we're not going to round 14.7 to 15, we're going to round 14.7 to 20. 860, we're going to round to 1,000. And here's a couple tricky ones. 0.031, we would round to 0.05. And 28.6, again, very tempting to round that to 30. We're not rounding it to 30, we're going to round it to 50. Why do we do this? And that's a good question to ask, because if you're sitting here and you're thinking, this is a very weird way of rounding, you're very correct. However, this is why we do it. Let's say I tell you to plot the point 5 and 0.5. Which scale makes it easier to plot that data point? Here is a scale that has not been rounded. And so what we want to say is, all right, well, where am I going to fit in 0.5? So when we look at this vertical scale, I know that 0.5 is going to happen somewhere in here, but this does not make it easy. Does it go here? Is is it closer to here? You see my point that this is very difficult.
Mm-hmm.
If we've used a rounded scale, where does 0.5 go? Well, we have this beautiful way of saying, oh, well, I know that 0.5 is exactly halfway in between here and here. And so this one is really easy to plot. So in general, why do we round? We round because this is not easy to plot points. And if it's not easy, it's not accurate. This is way easier and way more accurate. So that's the answer to why. All right, so let's do an example from start to finish now, where we're going to take a look at some practicing with these calculation of scale values, okay? So calculate the scale value to be used for the horizontal and vertical axes. Also assume that we're going to use standard lab graph paper, right, which has 25 squares horizontally and 30 squares vertically. So given the equation in words, substitute the values, and then solve. So we're going to do 1, 2, or 5. All right, so here we go. Speed versus time. This is a graph, and what we want to say is, okay, speed is going to be plotted vertically. Why is that? Because it's mentioned first in the title. That's where you'll see it. And so when we look at these values, we say, okay, to do the vertical scale, and let's take a look at what's been written here, we take the largest vertical value and we divide it by 30. This is the formula in words. Okay, so this is basically the formula to determine the vertical scale. This is the formula in words. So when we look at the largest vertical value, 13.1, 24.7, 35.2, we see that it's 48.1. So we take this largest vertical value and we sub it in here and we divide by the number of squares we have available, which is 30. We solve this and we get 1.6, and 1.6 is not an appropriate scale to use, so we round up to 1, 2, or 5, and that would be, in this case, 2. Okay? So now let's do the same thing though, and let's work though with the horizontal scale. So here, let's write it in words first. So the horizontal scale is the largest horizontal value and we're going to divide by how many squares we have available in the horizontal direction, and this question tells us that we have 25 squares available. All right, so now we take a look at our data. What is our largest horizontal value? And we see that it's 10.3. So we replace this with 10.3 divided by 25 squares available, and we now calculate. And we see that this value becomes 0.41. So we've solved, and we need to round this. So 0.41 becomes 0.5. Again, we need to say, is this a 1, a 2, or a 5? And 0.41 rounds to 0.5. And so here it is. An example where we've practiced and we've solved. You'll notice when we flip the page over, there's another couple of examples here that we have, and we're going to leave those for you to try on your own now. Okay, so using the guidelines that we've given, 1, 2, 3, 4, and 5, practice for this example, and we'll go over this tomorrow. And what I want you to do is I want you to stop when you get to this point, because this assignment we're going to do in class together, and it's going to be marked. So this example is left for you to finish, and we'll take up the rest of this in class tomorrow.